slightly will increase the nib. Now there's a boundary, and this will become normal. This everything is water. Refractive index, let it be mu2 equal to mu. The refractive index of the rarer medium, let it be 1. Mu1 equal to 1. Let me keep a point object O at a depth h. Now the ray is it's a real object. So what is the condition? A real object. First case, a real object kept in a denser medium and viewed from the other medium. So where is the viewer? The viewer is here. This eye. So is a going to view that one. Now we know it's a real object. So the basic idea of a real object, like it will emit the incident rays will diverge from that point where the real object is kept. Hmm? It is some sort of like some coin is what which is kept here. Okay, now we'll go for the ray diagram. Let me take out the video. Yeah. No. So the rays emitted by it. This will be the normal what we'll draw it here. So look at the rays. The rays emitted by this real object will diverge, will get refracted into the rarer medium. So the rays are moving from denser to rarer. So these are normal. So the ray definitely will bend away from normal. The ray will bend away from normal here. That okay. Now there's a refracting angle. So let it be I. Let it be R. Angle of incidence, let it be I. Angle of reflection, let it be R. So this will be I. The refracted ray will diverge from this point. It has bent more, no? Let me bend it very less. Okay, now. So here, if I produce it back, it will meet at this particular point. Okay, this will be the image I. The real depth. This is apparent depth. Okay, let me take this is P, this is N. So which rays will enter into the human eye? These refracted rays. So when an object will be visualized, when the reflected rays or the refracted rays enter into eye. So this human eye is able to see the let me bring it so it will be much easier. So the human eye is able to see this object because of the refracted rays will enter. But whether it will be visible for this eye, the object will appear at eye. And what is this eye? So this is the real object and there's a virtual image. Though object is here, when it is viewed, then it will appear at high. So shall I say that some shift is there, apparent. Actually, the object is here, but it will appear near to the boundary. So therefore, the word apparent is brought here. Now, what do you mean by here? The visualization. So, what do you mean by visualization? When refracted rays enter into human eye, the object is visible. When refracted rays enter into human eye, then the particular object will be visible, is telling. Means the rays emitted by the object after a refraction, if they enter into eye, then that particular image of object will be visible. When refracted rays enter into human eye, the image of object will write it. The image, the image of object is visible. Okay, fine. So there's a thing. So actually, object is at a depth h. So, but it will appear at a depth h. So this is called like appears. Appears means apparent. So what is h? H is a real depth. H is apparent depth here. Look at these symbols. These are very important. Okay, I'm interested in knowing that one. So let's apply the Snell's law. Now applying the Snell's law, mu2 sin I equal to mu1 sin R. And we'll go for paraxial rays if M is very close to the P. So it will be like almost like a normal weaving. You are weaving it normally. Let let M be very close to P, or normal weaving, or for paraxial rays, or considering paraxial rays, or considering paraxial rays. So then what will happen? The effect of this sin I will become tan I. Sin R will become tan R. So this will be mu2 tan I is equal to mu1 tan R. What is tan I? Tan I will be Pm by Pu. Tan R, let me write that clearly. Virtual. Yeah. Okay, what is tan I? Tan I will be Pm by Pu. Now what about tan R? Pm by Pi. I'm interested in Pi, that one. So mu1 by mu2 into Pu. What is Pi further? This will be Ha. Go for. Okay, this will be mu2 into h1 real depth. If mu1 equal to if this is air, this is a water, then mu1 will be 1, then the apparent depth will be, because mu1 equal to 1, mu2 equal to mu, if you substitute here. Already we have defined apparent depth and the real depth. So therefore when an object, real object kept in denser medium and when viewed from rarer medium. So where is the viewer? Viewer is in rarer medium. Then it will appear nearer. So it's very